This is what I usually go over when we do it as a hands-on, because these are the things you're going to need to know to be able to do routing successfully. But this is also important information for you guys. So just to know, what you need to know to be able to successfully do routing is you need to understand configurations and design tables, because that's how the pipes and tubes and elbows and everything work. They have configurations with a design table under them. So imagine, an elbow, one part, but hundreds of sizes inside that file, or a pipe file, or a tube file, or a flange. You also have to know how to use the design library, something that you would have learned in Essentials class. That's where you're going to go to get a lot of the routing parts, to drag and drop them into your assemblies, fittings and flanges and things. And then you also need to know how to do some 3D sketching. Very minimal, simple line 3D sketching is all you need to know. And you may not have to use it at all. That's what I say at the very bottom there. You may not need to do 3D sketching at all. You should always try auto route first, and then you can edit or change what the auto route did. But it definitely helps to know some 3D sketching before you try to use routing. This is just a quick few slides of what's included in the library when you start, or when you install SOLIDWORKS. Some tubing components, some piping components. There's also a bunch of electrical stuff that gets installed with routing. Routing does include electrical wiring and cabling. I'm not going to be covering that today, just the piping and tubing aspects. So there are quite a few things that come out of the box with SOLIDWORKS. Of course, this is not everything you're going to need. So, you're either going to have to model things up yourself, download them from 3D Content Central, or download them from supplier websites. Once you get them downloaded, there is a little wizard you can run through called the routing component wizard that will turn those parts into routing parts. That's more of an advanced thing. You learn how to do that if you come to the routing training class, or you can, of course, look for that in the help file. But it's a wizard that will turn your downloaded, simple part into a intelligent routing part so that you can use it and put something called route points in. So we're going to talk about tubing and piping today. And the first thing we're going to look at is tubing routes. So this is talking about bent metal tubing, flexible hoses, things like that. It can be used for both of these, whether it's copper tube, or rubber hose. So we're going to look at rigid bent tubing using 3D sketching. We'll also look at auto route for that. We'll look at flexible tubing, like a hose, with 3D sketching using a spline, and we'll look at auto route for that also. All right, so let's switch over to SOLIDWORKS here and take a look at doing a tubing route. I've got another computer set up next to me also as an attendee, so I can kind of see what you guys are seeing, hopefully, and I can see the lag time. And it looks like you should be able to see my SOLIDWORKS window, so I'm going to go ahead and move on here. One of the first things you're going to want to obviously do is turn on the routing add-in. It is an add-in that comes with SOLIDWORKS Premium, so I'm going to turn on the routing add-in. This is an assembly that I'm setting in right now. And if I look at my assembly, I can see that some of these parts, the little red fittings, have some words on them. And if I zoom up, those are actually things called connection points. It says C.1, C.2, and I'll wait for there's a little bit of lag here. There, now it looks like I've zoomed up on your screens. So there's a thing in there called C.2. That's what lets me know that this is a routing part. This part has been turned into an intelligent routing component. Ran through the wizard and turned into a route part because it's got this connection point in here. You'll either see connection points or route points, R points or C points. And you need to make sure you're viewing those in your view drop-down toolbar. If you don't have routing points turned on, you wouldn't be seeing those. So you can turn those off, but to do routing, you're going to need to see those on. All right, the easiest way to do routing is to go to the start and then go to the end and worry about what to put in the middle, rather than drawing and winding up at the middle. So I'm just going to right-click at the start connection point. Now these connection points have a lot of intelligence in them. When I right-click on there and say Start Route, that fitting already knows inside that connection point what size it is and what tubes should be able to fit in there and how deep the tube goes into that fitting. A lot of information. There are some options and some settings that I can change. Like, do I want to do rubber tube? Do I want to do copper tube, stainless steel tube, whatever? Right now it's set to rubber tube, so let me go change this. And I'm going to change to stainless steel tube. Just selecting this part file is all it is, a part file, out of my directory, wherever I have it saved, and it is in my design library in this case. That tube has a bunch of configurations inside of it, a bunch of diameters and wall thicknesses. I would have a big list here of diameters and wall thicknesses, but like I said, this fitting is smart enough to know what belongs inside of it. So it knows it's a 1/2 inch fitting, so the only tubes I can fit in there are 1/2 inch OD tubes. But I do get some choices of wall thicknesses. We're just going to choose the first one here. So it limits down so you're not seeing a million configurations in that list. Here's an option where you can use flexible hose. We're not going to do that for this one, obviously. This one's a rigid tube. And then it knows it's tubing, so you don't get an option to put elbows in here. It's going to do bends, a long piece of bent tubing. And then do you want to set the minimum bin radius for the center line, the inside, and whatever you want that to be. So we'll go with the center line of 1/2 inch is the tightest radius we can bend. We'll go ahead and say OK to that. That's called the route properties. It's going to start a subassembly now inside my larger assembly. So each tubing route, each piping route, each electrical route, any route is a subassembly. So it wants to know what template I want to use for that. And we'll use the route assembly inches. It's fine. As soon as I do that, it starts the new assembly, starts a stub, a pipe, a piece of pipe, a stub length sticking out of my connection point, puts me in that new assembly. I can see that in the tree because it turned that subassembly blue, the blue color. If I expand that, you can see I'm in that subassembly. There is a route that's been started in that subassembly. And I'm actually in a sketch. If you look in the top right corner, I see the confirmation corner. So I'm in a sketch inside this subassembly in a 3D sketch. If I look down at the lower right, editing a 3D sketch. This stub length, the endpoint on it is blue. I can grab a hold of that and drag it to any length that I want, make it as short or as long as I want. I can put a dimension on here if I want to. Okay. So I'm not going to in this case. We're just going to leave it at some length. But you could dimension this. Now instead of trying to draw now and end up where I want to be, I'm just going to go over to the end. And I'll wait for the graphics to catch up there. There you go. And I'm going to right-click that connection point and say Add to Route. I don't need to go through answering all the questions again of sizes and everything because it already knows that I'm in a route and I'm already using 1/2 inch tube of a certain wall thickness and I know what I want the bin radius to be and so on. So I don't have to answer all those questions again. It just goes ahead and gives me a stub. I can drag this stub length out to any length that I want. All right, I've got a start and an end. Now all I have to do is connect the dots in between them. I could connect the dots in between them by just drawing in a 3D sketch using lines. You don't have to worry about the arcs. It'll automatically put arcs in, so you would just use the line tool in a 3D sketch, very simple, to connect the dots, right? Connect the start to the end. Or you could use auto route. We'll show both here. Let's go ahead and show just drawing lines. In a 3D sketch, your tab key cycles between X, Y, Y, Z, and ZX. If you don't know how to 3D sketch, I'm not really going to go over that in this webinar. That's something you would need to learn before you get into routing. So if I'm going to draw a line over in the Z direction, and then maybe I want to go back in the X direction, and then maybe I want to go down in the Y, and then maybe I want to go over in the Z, and so on, drawing and drawing and drawing. And when you get to the end, let's see, let me get over here to the end if I can. Let's go like this, and let's go back up and over. I'm not going to draw right to the end. If you try to draw right to the end, it can get over-defined very easily. I just draw close to the end, and then I'm going to pick these 2 points and just do a merge relation. Very common in 3D sketches, merge relation. And you guys aren't seeing that graphics, are you? I've got my little pop-up toolbar up, but apparently that's not showing on the screen. Let's try this again here. I'm not seeing that on your end. There we go. Now you're seeing it. So we'll do the merge, and it joins those two together. So that's one way you could do routing, right? And then you could put dimensions on all these pieces if you wanted to, dimension them from the legs, dimension them through holes of other plates, make this line concentric through a hole or something like that. That's one way you could do routing. Let me undo and show you the much easier way to do routing. So here we are back to our two stubs, right? The much easier way is to just right-click either the start or the end, doesn't matter which one, on the end of the stub, and say Auto Route through a right-click menu. Now there are toolbars for piping and tubing, but I haven't gone to any of the toolbars yet. I've just done everything in routing through right-clicking, so much easier. So I'm going to say Auto Route, and it knows that you're going from that point, and it wants to know what other points you want to go to. So you go pick your other point, and it does an auto route between these guys. There's the quickest, shortest solution it could get. If you want to see other solutions, you can come over here and cycle through them. But because I put these guys at weird lengths, there is no other solution. If I had put the stubs at the same length, there would have been up, down, left, right kind of solutions. And you could cycle through them over here in the dialog box. So that's a little easier. Let me undo, and let's actually put a dimension on these guys to show you how that would work. And let's make these the same. So let's say 2.5 and 2.5. Now we'll get much more solutions on here. And then let's do our auto route. No, that one ended up in an overdefined. After you do the auto route, you can drag then and make it any size you want. You can delete any pieces that it did as the auto and draw your own pieces in. So auto route is a better way to get started than just drawing on your own. So that would be the example of that. Let's actually put that back in. Let's go back to what we had. And we'll do our auto route. And this time we'll go ahead and hit OK instead of canceling on it. We'll exit out of the sketch, which gets us out of the route sketch, right? And then it finally turns it into real pieces. It turns it into the pink tubes or gray tubes or purple tubes or whatever settings you have set color-wise in your library for tubes. I'm still down in the subassembly. That's fine. And if you go in the tree, expand the route, you can see your 3D sketch down in there that you could get to if you wanted to. There's also a folder called Route Parts that if you open it up, it's going to show you there's your one piece of tube. And if you look way over to the right of that display, it tells you that that tube is 28.324 inches long. So it tells you exactly how long that guy is. There are some export things that you can do to export out the tube bend list. To show either a person on the floor or an automated tube bending machine exactly, go out 3 inches, bend 90 degrees, go up, whatever, bend 180 degrees, whatever. That can be exported out too from the tubing toolbar. Let's do a flexible hose. So let's get out of that subassembly. Let's delete that subassembly, and we're back to where we started. We're going to do the same thing. We're going to right-click the start point. We're going to say Start a Route. Oops. There we go. Start a route. This time we're going to choose the rubber tube. And we're going to say use flexible hose. This is the option here that makes it a flexible hose. Not that I chose rubber tube. Not that I chose stainless steel tube. If you turn on and use flexible hoses, it doesn't matter what you've chosen as your tube part. It'll bend it and make it flexible. It'll use splines instead of lines. I do get to choose my wall thickness just the same. It already knows the diameter. We'll go ahead and say OK on this. Gives me my step length coming out of there. And this is a straight piece. Okay, this is how long you want it to stay straight coming out. So you could drag this guy really short if you wanted to, or you could make it long. It doesn't really matter. And then just the same, I'm going to go to the end and right-click and say Add to Route. And I'll get a little stub coming out of there that I can make any size that I wanted. And then I'll just do the auto route. Auto route is definitely the easiest way to do the tubes. So we'll right-click and say Auto Route from here to here. and it does a spline instead of lines. You say OK to this, and that's my hose. Now I can edit this spline, right? I can split the entity. I can add another spline point in here. I can right-click and show the sketcher triad and pull and drag on this spline. Oops, got to drag on a point, don't I? So insert a spline point, and then I can grab my sketcher triad and drag that spline in or out, up or down, right? And it's going to adjust the hose. So there's what my rubber hose looks like. If you violate your minimum bend radius, the hose will turn pink and dashed in the corners and show you that you've kinked too much. You can also use clips or holes in plates to route your rubber hoses. Otherwise, the hose is just going to be suspended there in space. Clips and things, that's a little more advanced. That's something you would get to in a routing training class. This one will also show the length calculation. If we go over in the tree, open up the route parts folder, this particular piece of rubber tube is 31.188 inches long. You can do fixed length tubes. You can get back in there, edit that sketch, basically right-click in the tree and say you want to set this to a fixed length. You know, you buy this hose in 4-foot long pieces, and if it can, we'll route the hose using that length and just give you slack somewhere, and then you can play with the slack, dragging the spline around. All right, so that's the tubing. Any questions on the tubing? I don't see any questions typed in, but if you do have any questions on tubing, you could go ahead and ask them now. Otherwise, you can wait till the end and we can go back. I'll just give you 30 seconds here if you need to type a question for tubing. Once you know how to do tubing, piping is just the same. It's just a little more confusing because you got to put in elbows and T's and things instead of just a straight piece. The clicks and the actions you go through are pretty much the same, though, for piping. All right, no questions yet on, oh, there's one. If I could see it, let's see, how do I expand this? It says, is the part name the best way to determine the length? You mean by going and looking in the tree, by going and looking over there? That is the easiest way to determine the length, yeah, for sure. You can also make since it is a subassembly, you can make a drawing and make a bill of materials, and the length will be in the bill of materials, for sure. Or I guess, actually, with as of 2012, you don't even need to make a drawing to make a bill of materials. You can make a bill of materials right here on the assembly without having a drawing. So, but yeah, if you're just trying to check and see real quick, looking in the tree is the best way in the part over there. I think that's the question you were asking. If not, type it in there again, and I'll look at it at the end. All right, let's move on back to our slide presentation here. And now we're going to look at pipe routes. So pipe routes are all kinds of things: PVC glued together pipe, welded pipe, threaded pipe, all those kinds of things. Rigid pipe that, not bent. It has elbows and T's where you need bends, pieces of pipe, either threaded or welded or glued together, right? Where the pipe engages into the elbows or whether it just butts right up against them, the flanges and so on. So we're going to look at doing piping with 3D sketching and with auto route. Auto route is available in there too. We'll look at the elbow selection tool, and we'll look at adding our own fittings and valves and so on, a T or a valve, or when we need to branch off and go a different way. Let's close this file and open up our piping file. Okay, this one looks a little different, but really the same idea. I've got some parts here. Instead of those little red fittings like before, now I've got some blue boxes here that have connection points on them. So you can turn any kind of part you want into a routing component. You just have to set up some connection points, usually inside of a hole or inside some diameter is where you're going to set a connection point. But it could be a pump, anything, a block like we've got here. All right, so we're going to go to this connection point. We're going to right-click and say Start a Route. Now this box, this connection point, knows that it's a piping connection point. It knows that it knows that it is a certain size, and so on. It knows whether it's threaded pipe, it knows whether it's welded pipe, and so on. So this one here is actually a threaded pipe. I don't want to use just my straight pipe. I want to use my threaded pipe here. And I've got a whole separate library of threaded. This may be the only thing you use, and then you wouldn't have to go choose. I have threaded and welded and PVC and so on. So it knows it needs to be 3/4 inch based on that size hole that I picked, or that connection point that I picked. I just need to tell it what scheduled pipe, what wall thickness I need. So we'll use the first one here. Now this is threaded pipe, so I wouldn't be using weld gaps, but there is an option here to use weld gaps. And as you run along, it'll put a gap between the elbows if you need that. There's also an option for use standard length. If you stock a bunch of 4-foot pieces of pipe on the shelf and you want to use as many of those as you can say use standard length, and whenever you've got a run of more than 4 feet, it'll use a 4-foot piece, a coupler, and then a small piece, or 10 4-foot pieces and then a small piece. So that is an option. With piping, you're going to want to always use elbows here. You can actually do piping and have it form a bend, but that's really tubing, so you wouldn't do that. Piping means elbows. And then you're going to tell it which elbow is the default elbow. All right, so we're going to go into threaded fittings, and I've got a 90 degree and a 45 degree. I have these elbows that exist. My default one is going to be the 90 degree. I'm going to use that the most. Okay, so that's what it's going to try to use in every corner. If it thinks that a 90 degree elbow doesn't belong, then it's going to ask me which one I want to use, and I can choose to a 45, a 35, whatever I may have in my library. So that's just my route properties like before. I'm setting up the properties of the route. We'll go ahead and say OK to that, and we get our template selection. We're going to use the inch template again, and I get a big stub, 3/4 inch big long stub sticking out of here. I can drag this to any length that I want. I can put a dimension on this if I want to, and we're going to come back and put dimensions on this in a minute. I'm going to do 3D sketching here rather than auto route. You could try auto route, right? But before I do the 3D sketching, I'm going to go to the end. Right-click the point where I want to end at and say Add to Route, just like I did in the tubing. That gives me a stub over here. Now all I got to do is connect the dots. Right? So we're going to draw lines in a 3D sketch, and we're going to stay down in the ZX plane. We're going to come out along the Z. We're going to go at an angle along the ZX, and this is why I'm doing sketching instead of auto route. Auto route's never going to give you angles unless it's the only possibility. Auto route here would have done some rigid X, Y, Y, Z, ZX lines in those directions. I knew I wanted to come in an angle. And then I'm going to come over here and just get close to where I want to be, somewhat in the right direction, not actually try to touch the end point where I want to exactly go to. Then I'll take those 2 points and do a merge relation between them. And that connects them together. Then it doesn't go over to find on me or flip weird on me or anything like that. All right, we're going to drag this guy down a little bit here, and as I drag, you can see my sketch goes crazy on me, right? We're all used to weird stuff like this happening, right? Especially in a 3D sketch. Let me undo. So, you got to be careful about what you drag and edit here, and you got to really take a look at what you got going on. The first important thing we need here really is this to be perpendicular to this. That's going to keep a lot of stuff from going crazy on me. And now I can pretty much just drag this up and down, and it goes very smoothly. Sorry, it's hard to see my dragging, through the GoToMeeting, but I think you can see where I'm getting. At least you're seeing the beginning and end results if you're not exactly seeing my dragging. So that perpendicular was the important one here. relation. Now we just need to put some dimensions in here. You can dimension from the endpoints to the other lines of the pipes. You can dimension just the stubs. So we'll make that 5 inches. Here's an important one too. We'll make this angle here 135. Why that's important is because it's going to, then we can use a 45-degree elbow there. If I use that leave that at some weird angle, it's not going to know what angle to put, what elbow to put in there. Let's come in and drag this guy out a little bit. And then let's put a length on here. So from this corner point out to here, we want it to be 14 inches. That's enough to fully define that sketch. And we'll go ahead and exit sketch or exit route. It's really called exit route when you're doing routing, but it's the same icon that you're used to for exit sketch. It's the same thing. The sketch, the route, same idea. So it goes in and looks and says, okay, I understand everywhere for the 90-degree elbows, but I got 2 corners where I don't think the 90s make sense. Are you sure you want me to use the 90s? And it highlights the corner there for you and says, do you want me to use this 90? If not, you can browse, which of course is what I want to do, and go pick another elbow. Now, what if I don't have an elbow other than the 90? Well, you can, on the fly right here, make a custom elbow and give it a path of where you want it to save it to. It will use the 90-degree elbow and modify the angle of it and make a brand new file at some crazy 126.5 degree angle if you really wanted to. I want to use pretty standard things. That's why in my sketch I went ahead and put that 135 in there to guarantee myself that I would be using a 45. So we're going to browse and use our 45-degree threaded elbow there. I have to pick which class threads I want, 2,000, 3,000, 6,000, so we're going to choose the 2,000. There was an option that I did not turn on. Use these settings for all other identical arcs. If I would have turned that on anywhere else that it had a 45-degree angle, it would have went ahead and put that in. I did not turn that option on, so I do have to answer this question again. You would have wanted to turn that on. And then it has no problem with the 90-degree ones. It goes ahead and knows what to do for those. So as soon as I hit OK, I get all the pieces and the elbows in there. Now, if we expand the tree for this one, this subassembly, you've got 2 folders and a pipe route. You've got components folder and route parts folder. So in the components folder, let me drag this window bigger so you can see. That's big enough right there. Move this guy over. So in the components folder, let me let your graphics catch up here. All right. You've got your elbows, and you can click on these and see which elbow is which. So a 90-degree, a 45-degree, a 45-degree, and a 90-degree. They'll highlight on the screen. And then you've got your pipes. So here, this pipe is 4.235 inches long. This pipe is 6.985. This one is 5.94 inches long. And you can click through the pipes and see. Now that one's 19.2. This one's 14.9. You could go back and edit your sketches, right, and change these if you wanted, and these numbers would all change. The question always comes up, is there a way to drive it the other way and tell it, I want this pipe to be 5 inches long. Tell it, I want this pipe to be 19 inches long. No, that is not how our routing works. Our routing is based on the sketch. Whatever you do to the sketch, it results in the pipes, not the other way around. All right, we'll drag this window back. And there's my pipe route. If I go take a section view in here, and let me drag this section view to somewhere inside the pipe. It'll take a second for your graphics to catch up. I'll wait. Like I said, I've got another computer sitting next to me as an attendee, so I can see what you're seeing, hopefully. So there's a section view. You can actually see with this threaded pipe, the pipe is engaged inside that elbow. How did it know to do that? How did it know how far to engage in there? All that intelligence was in those connection points. When you set up this elbow part, or these pipe parts, or the fitting parts, they all have that intelligence in them of how far to engage into them. It's engaging into the block up above, too. That's all set up in those connection points when you set these up as route parts. So if you haven't figured it out, that is the big deal about routing, is setting up your library of parts. Now, I haven't gone to my library really to get anything. Everything I've needed has already been in this file. If you needed flanges and fittings and elbows and T's, which we will go to here in just a minute, you would go to your design library. You've got a routing area, and then you've got a piping or a tubing area. And here's all different subfolders underneath there for things. So if you wanted to start with a flange, you could. You know, if you had this blue box saved in your library, maybe I would have dragged and dropped it out, you know, to start my route. It was already in the top level assembly, so I didn't need to do that. All right, we're doing great on time. We're going to do another route here. That route I did, you know, by hand, by drawing. This next one I'm going to do with an auto route. We want to branch off of here. So I'm still in the subassembly, but I'm not in the sketch anymore. If I want to get back into the route sketch, you know, I could right-click and say Edit Route, and I could change something about this. Okay. So let's get back in there because we want to change something. We want to add on to it. Your elbows kind of disappear. It just kind of goes to a more simplistic display, just showing you, you know, red pieces and yellow pieces, but you know, it doesn't really show you the elbows, the detail of the elbows anymore. That's so it runs faster. That's when you're in the sketch mode. Kind of a preview of what the pipes and elbows are going to look like. Now I'm going to go over to my library, and I'm going to go to a threaded T. So here's my threaded fittings, and I've got a threaded T here. Now, all these parts in the library, or at least most of them, I'm pretty sure all of them that come with SOLIDWORKS already have a mate reference in them. And any parts that you put in here, I would think you would want to put mate references in so that they snap right into place. So this threaded T has those in here. As soon as I drag and drop this guy out, it automatically sizes to the right size. I know you didn't get to see it size because of the graphics lag, but when I first dragged it out, it was giant, whatever the default size was. And as soon as I dropped it in here, it defaulted to a size. Because I'm editing this route, it knew what size to go to. So it went to 3/4. You're just going to have to trust me on that. So it will auto size. When I drop it on here, wherever I drop it on the pipes, it's going to automatically orient and mate itself, if you want to call it that, right? Orient itself to these pipes and snap into place. It will also automatically split this pipe into 2 pipes. Now, I still haven't dropped it yet. I still haven't released the left button on my mouse. The tab key will give you 2 options, this way or this way. Neither one of those are the way I want. So I'm going to go ahead and drop it, pick the thread class that I want. It already knows the diameter, 3/4 of an inch that I want. I just have to pick the thread class. And then, new in 2010, I think it was, so this has been around for a little while, this triad pops up, or there's an option for this triad to pop up. It's in your routing options, whether you want this or not. And you can then drag the rings, just like you use this triad for parts in an assembly, to orient these parts if you want to. And there's a compass, or a protractor, whatever you want to call it, an angle here that you can set, and set this to anything. So I want to go to, 90 degrees. So I'll snap to 90. Those are your 2 ways, either using the tab key or using that triad. If you want an exact specific direction, like you wanted to run off in 123.5 degrees, the thing you do is draw a reference sketch line first. Then when you drop your T in there, it snaps exactly to that angle. So that's a little more one of the advanced things that you would learn about in a routing class. Those are the 2 simple ways to orient your part. So now I move this around left and right. It's going to change where this piece and this piece are split at. These are 2 separate tubes now on either side of that T. And this is the new stub sticking out of the tube for me to continue on with my route. So it's kind of like doing add to route, but just by dropping a T in. Now I'm going to go to where I want to end at. I've already got my start. I'm going to go to my end up here at this other box, right-click, and say Add to Route. It's going to give me a stub coming out of there. Now there are also other T's, maybe not in my threaded library, but let me go to just regular T library. There's reducing T's, and you can create these. Maybe I wanted to go from the 3/4 down to a 1/2 inch or up to a 1.5 inch. I just used basically a 3/4 to 3/4 T, but you can do reducing T's or enlarging T's also. So I've got my start, I've got my end. What's the easiest way to get there? Auto route. So we're just going to right click either point, do an auto route, and then click the end point, and it automatically routes in between. Here you're getting a better idea of what auto route can do. It wasn't working so great in the tubing example that I showed you, but here, there's some orthogonal paths that it can follow. And I can cycle through them over here in the property manager. So this is one solution. This is another solution. Here's another solution. And all I'm doing is clicking through the arrows and seeing which one I like better. Here's another one. That's actually the one I like better, but I'm going to keep on going. And I can cycle through all these different solutions and see which one I like or which one is close to what I like. Remember, this is just a 3D sketch. I can always change and edit and get rid of or modify what it is doing automatically for me. So let's say this is the one I like. We'll go ahead and say OK to this. And now, it's an underdefined sketch. I can drag this longer. I can drag this down. I can change these. I can delete out a redundant piece if there was one in here and draw some new shape. If it's running through a pipe or through a plate and it's going the wrong way, I could delete out pieces of this sketch and draw my own pieces in using 3D sketching. So auto route just gets you most of the way there. You may need to modify what you've got. That looks pretty good for us. We're going to go ahead and exit out of our sketch, which should go ahead and put our elbows in and so on. This one's all 90-degree elbows, so we can just say use these settings for all. Oh, there is a 45, sorry. There's my 45. I've got to go browse for my 45 and say OK for that one. So there's that little piece of the route. And this is all in one subassembly, right? If I open this subassembly up in its own window, it's all in one subassembly, this whole entire route. And I'll wait for the graphics there to catch up. There you go. So I just opened this subassembly up in its own window. Then you could, of course, do a bill of materials, right? In 2011 and 12, I think it's 11, but I know in 12 for sure, you don't need to make a drawing to make a bill of materials. You can just do insert, bill of materials, tables, bill of materials, and do a bill of materials right from here. We'll actually make a drawing in a minute. I want to add one more thing into this route, so let me go back to my big assembly. And edit the route again. So I'm going to right click anywhere on the sketch, or you could do it from the tree and say edit route, which gets me back into the sketch mode. And I'm going to go over to my library, and there's a valve, a quarter turn ball valve that I want to add into here. So we'll drag and drop this guy in. He will auto mate into place as soon as I snap it anywhere on these pipes. Oh, you guys aren't seeing that, are you? Oh, there you go. So wherever I snap it onto a pipe, I want to snap it up here. My tab key then will flip the handle one way or the other way, because there's two possible ways this guy could be mated in there. Either connection point 1 at the top or connection point 1 at the bottom. It's just flipping the valve. So we're going to go this way. I could use the triad then to rotate it if I want. That comes up automatically for me if I wanted the handle to the front side, to the top side, whatever. I'm just going to leave it where it's at. Exit out of here, and now that's split that into two little pieces of pipe on either side of that valve. All right, we want to make a drawing for this. You could, of course, go make a drawing by hand. You could go, put a view on there. You can put a bill of materials on there yourself, but it's super, super easy to automatically do this. On the piping toolbar up here at the top is a button called Pipe Drawing. All you got to do is pick a couple options, and it'll go do all this for you. So let's hit Pipe Drawing. It says I've got to save this out first. Yes, I do want to save it externally. We'll just save it on my desktop. But I want to save all the parts internally. So I'm just saving out this subassembly externally. All right, what size sheet of paper do I want? We're going to go with a C-size landscape. And then, do I want to build materials on here? Yes. And what build material template do I want to use? We'll choose I've got a piping one. And then, do you want to put balloons on there, and do you want to show the route sketch? Yes, yes, yes. We say OK to that. And it goes and makes the drawing for me. Your graphics probably won't be able to catch up here, but I'm not just switching to a pre-existing drawing. It's showing pretty well on yours. That's not a pre-existing drawing. It just made that on the fly. I did not already have that made. So it basically took my sheet, put a nice 3/4 ISO view on here. Let's go ahead and shade that view. You can see it a little better. It ballooned all the items. I can, of course, move the balloons around. I could change the size of the balloons if I wanted to. It didn't balloon everything because it's set to not balloon identical items. You might want it to do that. So let's actually delete these balloons and auto balloon myself. Let's see. So we'll do auto balloon here. And we'll say do multiples. So now it's going to label out each piece. And it tells me over here in the bill of materials what I need. So I need 6 90-degree elbows, 3 45-degree elbows. I need 1 T. I need a 1/4 turn ball valve. And then I need 79 inches of 3/4 inch Schedule 40 pipe. So it's added up all the pipe together as item number 5. That's why there's a bunch of 5s out here. Actually, it didn't even balloon the pipes, did it? It just ballooned. Yeah, it ballooned one of them. So there's a 5 because it thinks it's one part. You can show detailed in here. If I go into this guy, I want indented. There is a way to show each piece separately. I don't know what I'm doing wrong here, though. There is a way to break it all out into individual pieces. I don't know why that's not working, but here I've just got a full length of all the pipes. You can show all the individual pieces in the bill of materials also, and it'll give you all those individual links. It knows all those. Those are all in a tree. It may just be the template, the bill of materials template that I have isn't working right. So that's the piping. A couple more slides here, and then we'll wrap it up with some questions if you have any. So I showed you there is some stuff that comes with SOLIDWORKS in the design library. You can actually download a whole lot more stuff right from SOLIDWORKS. It doesn't come with SOLIDWORKS just so that it all fits on the DVD is the reason we've been told, but you can go and download it. Inside your design library, at the bottom is a SOLIDWORKS icon called SOLIDWORKS Content. And you can download weldment profiles from there. You can download routing parts. You can download blocks for drawings. And inside, if you click on the routing folders, you do have to, of course, be connected to the Internet. There's ISO and DIN piping, and then underneath there is all the copper and library, a PVC library, a steel library, and all kinds of other fittings and flanges that you may need. It downloads it in a zip file. You just unzip that to your design library, and then you would have all those pieces. So that's where I got my threaded library, for example. You can also download parts from 3D Content Central or from supplier sites. You may need to take those parts, though, and run them through this guy, the Routing Component Wizard, to turn them into routing parts. So in the Routing Library Manager is a tool called the Routing Component Wizard that will just walk through turning a part into a route part. Here's a few other links. You may want to do a screenshot of this page or write a couple of these down. Like I said, this presentation is available for download, though. I'll show you that on the next slide. Some links of some more help, some more libraries, a piping and tubing design guide for SOLIDWORKS that somebody else wrote, kind of a tutorial. There, of course, is tutorials inside of SOLIDWORKS for piping and tubing that you can run through. And then here's some links for some additional libraries that you can download. Some of these will charge you to download. Some of these are free to download.